Hello, this is the second video to accompany the AMSP Further Maths Conference Teaching Activities for Vector session. In this video, we're going to look at some classroom activities taken from the integral resources. We're going to look at three separate ones, but there are many more on there. The first of them is based on the scalar product. Now, your students should be familiar with the scalar product, the idea that if we multiply the terms of two vectors together and then add them, this is one way of calculating the scalar product, and this is also the same number that you get if you multiply the magnitudes of the two vectors and the cosine of the angle between them. This method can be used to find the angle between two vectors, as can be seen here. Or similarly, it can be used to show that two vectors are perpendicular, because if the scalar product is 0, then the cosine of the angle is 0, therefore the angle between them is 90 degrees. So for example, if I were to find the scalar product of 5, 1, 2 and negative 2, 4, 3, this would be negative 10 plus 4 plus 6, which is 0, and that implies that these vectors are perpendicular. So the activity based on this is a matching activity that can be found in the integral resources. I'll briefly show you where that is. So when you log into the integral resources that you get for free for registering with AMSP, if you look in the Year 1 Further Maths resources here and into the vector section, this particular activity is in the scalar product resources, and it's these teaching activities at the top here that we're going to be interested in. All the three activities in this video are taken from the teaching activities. There's a brief introduction, and then the teaching activities themselves are listed in section 2, and you'll see this particular one here is this matching activity, activity 2. So this is the activity, and I would suggest finding this yourself on Integral, downloading it and having a go at using it before trying it with your students in the classroom. And the activity involves matching a value of t with a case of two vectors here and some information about them: perpendicular, maybe parallel, maybe that it's a certain angle. Okay, this is the second activity, also can be found in the teaching activities in Integral. This activity is best done with students in pairs. So, the idea of this activity is that students write down 3 points, use these to find the vector equation of a plane that passes through these 3 points, and then convert that to a Cartesian equation and check it. If it's done in pairs, students can do, say, steps 1 to 3, and then pass it over for another student to do step 4 and 5. I'll run through quickly what that would look like. So for example here, write down the 3D coordinates of 3 points A, B, and C. So let's have, just as an example, 0, 1, 3, 1, 2, negative 1, and 3, 0, 2. In the next step, in step 2, we're going to find the vectors AB, AC, and BC. And crucially, this is only going to work if these aren't parallel to each other. So in this example, AB is 1, 1, negative 4. AC is 3, negative 1, negative 1. And BC is 2, negative 2, 3. And then finally, in step 3, we can write down the vector equation in the form OA plus lambda AB plus mu AC. So I would get a vector equation that looks something like R equals OA 0, 1, 3 plus lambda amounts of 1, 1, negative 4, plus mu amounts of 3, negative 1, negative 1. At this stage, I would suggest they swap with another student and try working out the Cartesian equation for the vector equation they've been given. So the vector equation can be written as 3 separate equations. X is lambda plus 3 mu, y is 1 plus lambda minus mu, and z is 3 minus 4 lambda minus mu. You can then use simultaneous equations to eliminate lambda and mu. I'll not show the working on here, but you can try it for yourself if you want. And this eliminating lambda and mu in this example would give 5x plus 11y plus 4z is equal to 23. Finally, that was step 4. In step 5, we can try substituting in the original points into the equation. So for example, the point 0, 1, 3, that would give us 5 times 0 plus 11 times 1 plus 4 times 3, which is 11 plus 12, which does equal 23 as we expected, and we can check points B and C the same. There's also quite a nice extension here, which is if students know how to get the normal to the plane, they can check that the normal to the plane is perpendicular to the vectors AB, AC and BC. Finally, the third example, and again this can be found in the teaching activities, is a rich task. There are many of these rich tasks scattered through the further math resources. It's really worth looking for these within the teaching activities, see if you can find some rich tasks. And this one's in the handout for this session, which you can also download from the website. So I suggest having a go at working through this and thinking how you might use it with your students. So I'll leave you with a couple of things to think about, which is, first of all, these teaching activities are deliberately not sets of textbook questions. They're alternatives to textbook questions. So first question is, how do activities such as these support students' learning? And then, what is an appropriate amount of time to devote to these activities in your classroom? 2 questions to leave you to think about.